So, hello, I guess we can get started then. And I will write this bigger, the equation in the context, y equals 1115 to the point 932. Oh, sorry if you hear stuff in the background. I have other family over, and they do lots of sounds, so yeah. And what we can do, sorry for my voice, I'm a little tired also as well, but what we can do is this equation. So, the context. After a change in management, the number of complaints per month that a business receives from its customers can be modeled by the function y equals 1115, 0.932 to the x. In this model, x represents months since July 2018, and y represents total number of complaints received in each month. So the first question, by the way, this is from a test for one of my assessments that I got in the past, and I thought this would help you. So we're trying to figure out the contextual meaning of it. So here's a hint. In this model, X represents the number of months since July 2018. So that's a good start. And the other, let me underline that part as well. Oh no, that didn't work. But okay, we're just gonna leave it like that. And 2018. And then what's the other part that says? And Y represents the total number of complaints received in a month. Let me make that line better. Received in a month. And yeah. And what we're trying to figure out is that what does the 1115 mean and what does the 0.932 mean? Like, what are the meanings of them, context? So what we can see is that the 0.932, wait, let's start with the 1115. So it says here that Y represents the total number of complaints received in a month since July 2018. So this means the 1,000 is the starting amount of complaints. And then what about the 0.932? Oh, we're going to also mention, since he likes better context, it's since July of 2018. And then the 0.932, well, I hope you can see this calculator, but I think you can. Not all of it, but we can just subtract the 1 minus 0.932 to see what percent we get. We get a percent, so when we subtract from the calculator, 1 minus, oh, let me turn it on. So what we get, 1 minus 0.9, oh, I didn't put the minus sign, oops, sorry. 1 minus 0.932, we get 0.068. Now what we have to do is, this is not a percent. We gotta move it 2 spaces to the, left to make it a percent. To the right, I mean, sorry. And after this, we get 6.8%. But remember, it's a decreasing model because it's less than 1. It's B is less than 1. B is less than 1, so it's decreasing. I'm gonna put DEC for short. So this will be negative. And the 0.932 means it's decreasing at negative 6.8% per month. It's decreasing 6.8% per month. And the next part of the problem is that use the model to find the number of complaints after 7 months. So what we can do is just plug it in for X. I'm just gonna put into X. And what we get is Y equals 1115 to the 0.932, 7 equals what we get. So let me pull up my calculator again. And 1115 to the 0.932 to the power to 7. And we get 681 complaints. And you may ask that, oh, why isn't it this decimal. Well, you can't have decimal amount of complaints because that would be weird. And next part of this is how long till the number of complaints is 400. So let me remove all this stuff. Let me see if I can remove it somehow. Let me see if I can move this a little. I think I can, but let's try it. We're going to delete this. We're just going to move it off to the side because that's pretty straightforward what we did. And what we got to do now is, after this is, so what's asking us, I'm going to do it right here at the bottom, is 400 is equal to 1115 to the 0.932 to x. So we have to solve for this x. We have to figure out what it is. What is it? How many months is it? How many months? Months. Am I right? So I'm going to scroll down, and the first step, let me rewrite this problem again, which is 400 is equal to 1115 to the 0.932 x. So the first step we gotta do is simplify as much as possible, which is this, dividing it like this. Divide the 1115, and after that we get 400 to the 1115 is equal to the 0.932 x. Now what do we have to do? Well, let me copy it again, and we're going to do 400 to the 1115 is equal to 0.932 x. So what we have to do is multiply the logarithm, which times the log on your calculator times the log of this on your calculator. And what we will get is something interesting. So on this side, we will get log 400. And I like keeping it like this, not already solving into the calculator, because we won't get an exact answer if we round it. And this will turn into this. It will turn into this. It will always work for every single logarithm. It'll turn into, so I'll use pink. No, I'll use this color. So it'll turn into x times the log of 0.932. This will work for whatever logarithm you have. Sorry for the sounds. But now we're going to write it out like this. Now I'm going to use, it's going to be x times the logarithm of 0.932. Oh, I forgot to close it. Sorry. And after this, what we get is we just have to divide this logarithm by the other logarithm. Logarithm of 0.932 over this logarithm of 0.932. And after this, let me see if I can do something awesome with this. Let me see if I can do something. And I'm going to make a copy of it. So Ctrl V, and we're going to move it down. What we get here, let me change it to final color. What we get here is equal to x, and I forgot, I didn't copy everything, but what we get here is equal to x. So after this, what we get is, let me move this to the side, let me move this up where you can see it. Let me bring it back. Let me move it to the side over here where you can see it. Oh no, it won't let me. Wow. It's kind of mean to me today, but let's see. Right there. So what we can do is we turn it first our calculator on. Let's clean this up. So log of 400 divided by 1100 15, close it again, and then divide it by the logarithm of 0.932. And then what we get in our calculator is something interesting. 14.5570756. So we're going to round this up by the thousandths place, so it'll be 14.557. And that is our answer for the logarithm. And I hope this helped, because this is basically what he expects you guys to do. This is what I did for my assessment, and we'll see if we can work on another assessment problem to see if you understand it. And that's all.